Okay, so the next section we're looking at is slope and rate of change. Okay, so section 3.4. So what is the slope? So the slope is defined as a slant or a steepness of a line. Okay, so that's what we're defining as slope. And so what we want to know about slope is equal to a variable m. So the variable for this chapter, right? And if you move forward in algebra-based course, m is what is represented as the slope. So slope is equal to m. And when we're talking about the slope, what we're talking about is the change in the y value over the change in the x value. So let's look at a problem here. So change in the y's over the change in the x. So when you're looking at a slope, what we're looking at is the change in the y's. So a rise, how are the y values changing, over a change in the x, which is considered the run. How are the x values changing? Okay, so you have a rise over a run. Okay, so the slope basically helps you be able to go from one point on a line to another point on the line. So by providing a rise and a run, you're able to go from one point on the line to another point on the line. And so formula-wise, we have a formula. So given two ordered pairs, so this is an ordered pair, x1, y1, and this is an ordered pair, x2, y2. And so when we take the difference, y2 minus y1 over x2 minus x1, we are able to identify the slope of the line. So for this here, we have a point. This is 0.03. Here I have a point -2, 0. So let's see what that looks like when we use the formula. So y2 is 0 minus y1, which is 3, over x2, which is -2, minus x1, which is 0. So a direct substitution, x1, y1, x2, y2. So the formula says you do y2 minus y1 over x2 minus x1. So when I do that, I get -3 over -2. So we get a slope of 3 over 2, a rise over a run. So I can rise up 3 places, 1, 2, 3, and run over 2, 1, 2, and I get on the line. I could probably do it again, 1, 2, 3, and run over 1, 2, and I would still be on a point on the line. Okay, so the slope, you have the slope is always going to be represented by an m. Okay, it represents the change in the y's over the change in the x's, which is a rise over a run. And what you want is you want the formula. So given two ordered pairs, you should be able to identify the slope of the line. So let's see. All right, so we're looking for the slope. So given these two ordered pairs that are on a line, we want to identify the slope of the line, okay? So you want to label your ordered pairs, x1, y1, x2, y2. So you label your ordered pairs, and then we have a formula, right? So our formula says the m is always y2 minus y1 over x2 minus x1. So we're going to just directly substitute everything in. -3 minus 5 over 2 minus -1. All right, so what now? So now we would just simplify. So -3 minus a 5. So the signs are the same. So we'll be looking at -8 over. And then 2 minus a -1 would give us a plus. So we would get a 3. So 8 over 3 is what we end up with as our slope. So -8 over 3. So let's look at this. Let's graph this just so you can see. One thing that is important to understand is that the slope is not a point. The slope is a rise over a run. I cannot graph negative 8 over 3. I cannot graph negative 8 over 3. I can only graph the ordered pairs. So I can plot the ordered pairs and graph the line, and then I can show on the graph how the slope is used. But we cannot actually graph the slope. The slope is like directions. It's telling us how to go from one point to the other. So let me show you. Negative 1, 5. So negative 1, 5, 2, negative 3. All right. So we have this graph here of this line. So I have a slope that says negative 8, 3. So here's what that means. It means that from one point to the other, I can go from start at one point, and using the slope, I can get another point on the line. So I'm gonna start up here. The negative tells me that my rise is gonna go down. So from this point here, I'm gonna go down 8. 1, 2, 3, 4, 5, 6, 7, 8, and I'm gonna go over 3. 1, 2, 3. And I end up at the other point on the line. So the negative 8 represents going down 8, and then the positive 3 means going over to the right 3. Okay? So the slope basically what? Showed me how to go from one point on the line to another point on the line. Okay? That's what the slope does. That's all you're doing. It's using given ordered pairs to substitute into the slope formula to identify the slope. All right, let's look at another one. Okay. So negative 1, negative 2, and 2, 4. So again, label your ordered pairs. Label your ordered pairs. And then you're going to use those ordered pairs to substitute them into the formula so you can identify what your slope is. So my ordered pairs, so I have y2, so m is equal to 4 minus y1, which is negative 2. Make sure you do a direct substitution. And then x2 is 2 minus x1, which is a negative 1. So I got double negatives in there, right? Double negative, double negative. So I end up with 6 over 3. And so we want to simplify that. What does that give us? It gives us a 2. So the slope is 2. Now, in its most simplified form, the slope is simply 2. But I want to show you what it looks like on the graph, because the slope has to always be a rise over a run, okay? So we have two ordered pairs. So we're going to plot those points. Remember, you have to plot the points. I'm plotting the points, not the slope. The slope is not a point. All right. You have to know the vocabulary. You have to understand so you can help your brain understand what's going on. I'm plotting the points. The points are the only thing I can use essentially for me to get this line right now. That's all I have. So -1, -2, and then 2, 4. That's my line. Now my slope is 2. What does that mean? It means my rise over run, right? And so essentially what should happen is I should be able to start at any point on the line and use the slope to get to another point on the line. So my slope is 2. What does that mean? It means I can rise up to 1, 2, and then there's always got to be a run. So my run, what is my run? Because it's a whole number 2, what is the denominator on a whole number? Well, it's an imaginary 1, right? But we don't write it as a 2 over a 1 because that is improper. However, we have to understand it that is always understood as a run of 1. So if you don't have a visible denominator, here I had a 3, I knew I was running over 3. Here, my 2 means that I'm rising up 2 and I'm gonna run over 1. And look what happened back on the line. And we can continue to repeat this. So I can move up 1, 2, run over 1, end up back on the line. Rise up 2, 1, 2, run over 1, back on the line. Rise up 2, 1, 2, run over 1, back on the line. That's what a slope does. The slope can get you every single point on the line. You can start at one point and use the rise over run to just keep getting more and more points on the line. Okay, so you would represent the slope as a 2, but you would understand that it is a 2 over a 1 because the slope is always rise over run. Okay, all right. So let's look at one more slope. All right, let's find the slope from the graph. All right. So let's say instead of them giving you the ordered pairs, they give you the graph with two points bolded. So you have the line, and then you have to find the ordered pairs yourself to find the slope. So given a line, you identify your own ordered pairs. So let's look at what these ordered pairs are. So this is 3, and this is -2. So I have an ordered pair here, 3, -2. And then I have an ordered pair here. This point is -1, 2. All right. So we have a line. So given a line, if they give you a line and they tell you identify ordered pairs and find the slope. So you take 2 points and you identify those 2 points and you label them as your x1, y1, x1, x2, y2, and then you identify your slope with the formula. So I'm going to label x1, y1. x2, y2. And if you label them the other way, that's perfectly okay. Just substitute improperly and you'll still get the same answer. So my slope is y2 minus y1 over x2 minus x1. So what's that look like? -2 minus 2 over 3 minus -1. -4 over 4. So we have a slope of -1. We have a slope of -1. So what does that mean? That means that from this point or from any point, I can rise and run and I can end up back on the line. So because it's -1, that means that we're going to go down 1 and then run to the right 1. So the negative means down, and then you always run right. So down 1 over 1. You see that? I can keep getting back on the line. So if I start up here, I can go down 1 over 1. I'm on the line. I can go down 1 over 1, I'm on the line. I can go down 1 over 1, I'm on the line. Down 1 over 1, I'm back on the line. That's what the slope does for you. The slope just shows you how to go from one point on the line to another point on the line. So without having any ordered pairs, we can get all these ordered pairs if we wanted to keep going and do this over and over again. Okay? So the slope is -1, but when you're actually using it to see how to go from one point to another, you make sure that you do the rise and you do the run. And so when you rise, when your slope is negative, that just means you're going to rise down instead of rising up. Okay? So given two ordered pairs, you should be able to identify the slopes simply by substituting them into the formula. That's all you do. Or given a line, find two ordered pairs on the line and then plug them in to the slope formula. Either one works. Either way works. Okay? All right, beautiful. So make sure you write your slope formula. You will be able to have it with you for your test, but you still need to make sure you practice it, because if you know it, it just makes it easier. All right. So let's look at slope. So let's look at these two problems. All right. So here we have these two ordered pairs. So work those and see if you can identify the slope for each. Okay, so hopefully you work those. I had to pause it for a second. My phone was ringing. I know y'all heard that. All right, so 4,3 and 4, -2. So let's look at what this would be when we plug them into the slope formula. So you should label them. Right, you should label them. And so your slope formula right? So those are subscripts, y2 minus y1, x2 minus x1, just so you know which is which. So when I substitute them in, -2 minus 3 over 4 minus 4. So we get -5 over 0. Well, what does it mean when you divide by 0? Well, dividing by 0 does not equal 0. Dividing by 0 equals what? Undefined. It's not possible to divide by 0. So this slope here is undefined. Okay, this slope here is undefined. So let's just look to see what this looks like. When we graph these points, we get 4, 3, and 4, -2, which creates a vertical line for us. Okay, a vertical line for us. All right, let's look at the second one. So remember, the slope is what? Steepness or slant. Well, there's no slant. There's no steepness. It's just a vertical line. So its slope is undefined, okay? Then we have x1, y1, x2, y2. So here, (1 minus 1) over -4 minus 5 gives us 0 over -9, which leaves us with 0. So 0 divided by -9 is 0, okay? So we get a slope here of 0. Well, let's graph this one and see what happens. So 5, 1, -4, 1. So what happened there? Well, we ended up with a horizontal line. We ended up with a horizontal line. And so what are we doing here? Well, we're introducing two special cases. So we already kind of saw a vertical line and a horizontal line in a previous section. So we're going to add to that. So we have vertical lines and we have horizontal lines. So what we've seen so far is a vertical line means x is equal to some constant. Well, the slope of a vertical line is always undefined. So this would be x equals c. So remember, the vertical line is always x equal to some constant. So when we look at this original problem here, this first one we did, 4, 3, and 4, -2. Well, what is that? The x is the same in both. 4, 4. The x is always equal to 4. The x is always equal to 4. And so the x is never changing. So that means its original equation is x equal to 4. That would be the original equation for this problem. It means x is equal to 4 because look what happens to the line. And so x equal to 4 would be this equation and its slope would be undefined because the slope of a vertical line is always undefined. So it's just a rule. And when you learn the rule, it just makes it easy for you to see what to do immediately. All right. So then horizontal lines means the y is equal to a constant and the slope of the horizontal line is always 0. the slope of the horizontal line is always 0. So y equals c here. The line is always horizontal. So on this example here, 5, 1 and -4, 1, the y's are the same. So this equation would be y equals 1. It creates a horizontal line. Anything that's a horizontal line means it's just y equal to some constant. And so there are just generic rules. And so when you see certain types of problems, you can automatically know what it means, okay? So you use given two ordered pairs, you use the slope formula to find the slope. And then you have special cases where if you have a vertical line, the slope is automatically undefined. If it's a horizontal line, the slope is automatically 0. But again, if you don't learn that part, you can just always know that if you graph the line, pick two ordered pairs off that line and plug it into the slope formula, okay? All right. Now, the last thing that we are introduced to in this section is the slope-intercept form. The slope-intercept form of an equation of a line. So the equation of a line. So we've been given the equation of a line. We saw that from 3.1 when we had x's and y's in the equations, right? X components, y components. So the slope-intercept form of an equation of a line. So the equation of a line contains usually x's and y's. So the slope-intercept is an actual form that we like to have the equation in so that we can graph it easier, essentially. So the slope-intercept form of a line is this: y equals m times x plus b. So this is the slope-intercept form of a line. This is something you need to know. All right, so slope formula, slope-intercept form. Okay, so even though you can have these with you on your test and they'll be given to you on your problems for your midterm and final, the formulas, you still want to know them for yourself. It just makes it easier. So y equals m times x plus b. So in this form, the m is always representing what? The slope. And the b component is always representing the y-intercept. Okay? The y and the x are going to remain y and x. Okay? Y and x stay y and x in the equation of the line. All right? So the slope is going to have a value and the y-intercept would have a value. So we just want to be able to identify the slope and the y-intercept from the given equation is where we're going to begin. So let's say we have y is equal to 3x plus 2. Well, what does that mean to us? Well, it means that the slope is 3, and it means the y-intercept is 2. Well, what is a y-intercept? And I just want to make sure that we understand this. A y-intercept, remember, is a point that's on the y-axis. So what would that look like as an ordered pair? And that's just because I want to make sure you understand it. So 2 is the y-intercept. So as an ordered pair, it would be looked at as 0, 2. It would be looked at as 0, 2. So given an equation of a line, you should be able to identify the slope and the y-intercept of it. Okay? All right, so let's look. Y is equal to 1/2 x minus 5. So what's the slope? 1/2. What's the y-intercept? -5. And if we had to write it as an ordered pair, it would be written as 0, -5. Okay? I want to make sure we understand that. Let's look at this one. 2x plus y is equal to 6. We need to identify the slope and the y-intercept here. That's what we're doing. So when we look at this equation, the only way you can identify the slope and the y-intercept is when it's in the slope-intercept form. So you cannot identify the slope. So you can't tell me, oh, the slope is 2. You don't know that. You can't know that because it's not in the y equals form. It is only m when it is on the other side away from the y. So you cannot identify the slope and the y-intercept from a given equation unless it's in this form. It has to be in this form in order for you to identify the slope and the y-intercept. So you can't tell me for sure that this is m because it doesn't say y equals. So I'm going to isolate y essentially. So in order to find out what is the slope and the y-intercept, I'm going to get y by itself. So we're going to subtract 2x on both sides. So y equals negative 2x plus 6. Well, now I know the slope is what? Negative 2. And the y-intercept is 6, which will be written as 0, 6. Okay? All right, let's look. (3x minus 2y is equal to 8). 3x minus 2y is equal to 8. So we are trying to identify the slope and the y-intercept here. So we can't do that unless it's in the slope-intercept form. So what is the slope-intercept form? It's y equals mx plus b. So when you're trying to identify the slope and the y-intercept from a given equation, what you do is you basically solve for your y. So you basically solve for y. All right, so you solve your equation for y. So how do we do that? Well, the first thing I would need to do is what? Move the 3x. That's from chapter 2, right? So negative 2y equals negative 3x plus 8. Now what? Now we're going to divide everybody by negative 2 because what is the goal? To solve for y, which means get y isolated. Because I don't know, this is not m. That is not m. How do I know it's not m? This is not m and this is not b because this is not just y. So you cannot say m and b until y is isolated. So when my y is isolated, then I can say, okay, this is the m and this is the b. So I divide. You should divide everybody separately. So y equals negative 3 divided by negative 2. Do not use decimals because slope is what? Rise over run. You should never be using decimals. You should always keep everything in its fraction form, just lowest terms. So 3 over 2x. No mixed numbers either. And then 8 divided by negative 2 is a negative 4. Watch your signs. So what is my slope? My slope is 3 over 2. What is my y-intercept? Negative 4. Which would be written as 0, negative 4 if I had to write it as an ordered pair. So given an equation, you should be able to identify the slope and the y-intercept from that equation. Sometimes it'll already be in the y equals form for you. Sometimes you're going to have to solve for y first and then identify the slope and the y-intercept. Okay? All right, hopefully that makes sense. Oh, and I think that's it. All right. I'm going to put 2 up here real quick for you to do. So we're looking for the slope. So negative 4x plus 3y is equal to 12. So you should see if you can identify the slope and the y-intercept of that problem. So you should pause it and work that problem, okay? So what you should have done was added the 4x because we're trying to get y by itself. And see, I wrote the x term in front. Now, if you wrote the x term behind the negative 12, it's not wrong. But we also want to make sure we remember the form. The form is mx plus the b. And so the x term should be before the constant b term. All right. Then we're going to divide everybody separately by 3. So we end up with y equals 4 over 3x minus 4 because negative 12 divided by 3. So what is the slope? 4 over 3. What is the y-intercept? -4. All right. So if you didn't get it, you probably messed up a sign. You didn't divide properly, or something simple and small. Okay. So you have the slope formula, and then you have the slope-intercept form that you need. So the slope formula, y2 minus y1 over x2 minus x1, given two ordered pairs, you use that. And then if they give you an equation and you need to find the slope, you put it in y equals mx plus b form, and then you can find your slope like that. Okay? So 3.4, slope. That's it.